Okay, so as I mentioned, the next couple lessons are going to be new tools for you to use to take derivatives. We're going to spend a lot of time taking derivatives. You're going to get very good at taking derivatives, whether you want to or not. It is a crucial part of this class, obviously. Today, we're going to talk about how to find the derivative of a product or a quotient. In other words, how to find the derivative of a function that has multiplication in it, how to find the derivative of a function that has division in it. But before we do that, let's make sure we're all on the same page with the power rule. Please solve that opener. I'll wait. And sing the Jeopardy theme. Do, 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 do. Allie, what do you got?
What do you got?
20x cubed plus 18x equal negative 7 plus 6x to the negative 1/2.
Hold on, I gotta write that down on the visual learner. I had you for a little bit and then I lost you. I got the attention span of a goldfish. All right, give it that color choice, Allie.
Whatever.
What's your problem?
Blue.
Blue. Which blue? I got 3.
The first one.
The light blue.
Yeah.
Okay. All right, go.
20x cubed plus 18x to the negative 7 plus 6x to the negative 1/2.
How are we feeling about that answer?
Good.
Question, or you agree?
Do you have to put, like, if you have negative x?
Oh yeah, I'll get to that in a second. Other than that, you're okay. Okay, let's give it up for Allie. Well done. So the question was, what about the negative exponents? Again, for now, it's okay. If you were feeling fancies in your pantsies, you could have done this. But you didn't have to at this stage. Later on, after we're more comfortable with all this malarkey, then we will start talking about those kinds of things. Okay. Thank you very much, Allie. That was a good warm-up. We're ready to rock and roll. Okay, so today you should be able to find the derivative of the product rule. Okay, because the title of the slideshow is product rule and quotient rule. What do you think the next one is? I'm so happy you're here, Liam. And then I just locked up my thing and went through the whole slideshow in about a second. God, these clickers are crazy. Let's try this again from the start, kids. You all got that, right? So start on your homework. Why does it keep... What in... Oh, there's the pro... Oh, you little bugger. All right. Trying this again. This is like trying to teach old people how to find their email on a library computer. Okay, so there we go. Thank you, Liam. Quotient rule, excellent. We're going to talk about some higher order derivatives. Like, just imagine this. How much fun is it going to be to find the 5th derivative of a function? It's going to be a blast. Some of you, however, will cry. I'm not mentioning any names, though, Kush. And of course, you should eat more vegetables. It's good for you. Builds character.
Technically. Yeah, I'm a soccer player.
Technically what?
Nothing.
Do I have a non-vegetable in that picture?
Yeah.
No, they're technically not all vegetables.
Don't they?
There's literally bananas in the
I'm
back.
not going to say anything because...
There's no bananas in the... Oh,
No,
there is a
top
banana
right.
in the back.
There's-
I apologize.
Well, also keep
I should be more careful in my Google searches.
I see this vegetable for you.
Cucumbers.
not because they're...
Cucumbers are a fruit?
No, technically, carrots are a root. Those are shoots.
Carrots are not a fruit.
I
What
said
about-
root?
Guys,
Roots.
guys,
Vegetables are a thing in the section.
what about seedless grapes?
What?
seedless grapes.
Those are genetically
GMO.
engineered.
Yeah, they were
They were originally a
Yeah.
fruit that was genetically engineered.
tortured by.
They'll probably bring
What
about.
are they? Monsters?
I'm sorry?
So then what are they? Monsters?
Yes.
No, they're genetically engineered fruit.
Yeah, I mean, I suppose a person has two or three legs and lose an arm, they're still a person, so, you know. Grape's still a fruit, it has no seeds.
Okay, just for more practice, knowing what we now know, and because you need some practice doing algebra, please find the derivative of h of x. And, more importantly, label it correctly. I'm going to talk while you're doing this, by the way. When we were doing limits, some of you got all loosey-goosey with your notation, like you're doing limits, and you didn't write the limit statement, you did this. You have to be careful when you're doing this stuff. There are some problems where you'll do some algebraic work first, then you'll take the derivative. That needs to be clearly labeled. For instance, there's some algebra you need to do first to this. It should be labeled as h of x. Then, when you take the derivative, you would label it as h prime of x. Okay, carry on. Are you lost, little girl?
Can I use your outlet?
Mi outlet is su outlet.
Thanks.
De nada. Don't hit your head.
Okay, so can I just use your charger?
Mi charger as su charger.
Thanks. Wait.
Have you got? Oh, you didn't finish it. Give me a second. Did you finish? No. Stop.
You all good over there? That old plug-in thingy giving you a challenge, or?
It's just not working.
It's working, I was just using it before.
So I got. Oh, did you get it?
Poor craftsmen blames their tools.
Oh, you guys are slow. You want to go over? I already got it. Yeah, that's what I got. What?
Am I done?
Okay.
Is it normal setting for x squared plus 4x?
Wow, thank you though for yourself.
Keep it nice.
I thought we were friends.
Yes.
Alpha play. Just like you got it.
No, sorry, we're not done. I'm still done.
I quit club soccer 2 days ago as well. That's why I was still playing. My text. That is crazy. You're not opening your pod.
There's pen stuff on the floor. Grab a pen. Excellent. Now, on the side, about 3 inches from the edge of the board is cap.
What?
3 inches from the side of the board cap. Not that guy though, don't hit that guy. Oh God, put that guy away. There you go. Now, second one from the top, yeah, that one. Choose a color. Shh. Okay, Dimitri is gonna teach us, well, you're gonna have to conserve space there, Holmes.
On my bed.
Okay, now you can switch to eraser. Click on that. No, back that, yep. No. Oh, crikey. Hold on, I got you.
Oh, wait, I
I got
got
you,
it.
babe. Okay, you're good. Oh, no, don't click on that again.
Alright.
Click on the pen again. Okay, good. Now click on eraser. You're doing a great job, Dimitri. Now erase what you want to erase. There you go. Now go back to pen. Choose a color. Ooh, red.
Should I just write out the answer, or do you want me to?
No, we want to see the work.
Okay.
We're yearning for some learning. Are we not?
Yeah.
Good. Start over to the left a little bit. I mean, the board's big, but not that big. All right, go crazy. You realize we're recording, right? That'll be an easy one to explain. All right, you good?
Yeah.
All right, while you're up there, please give Dimitri your full and undivided attention. Could you tell us what you did, please, sir, for those of us that can't follow along?
I FOILed it out and then added the two like terms and then took the derivatives.
Love it. Let's give it up, huh? Just, wait, do me a favor. Click on the pen again.
Yep.
Good. Now click where it says pen. Excellent. Put that back on the front of the board. Where the little, nope, to your left. Where the little pen, there. Oh, there you go. Beautiful. Now, just in Dimitri's defense, he had that work done before he accidentally clicked and it said multiply it out and use the FOIL method. And then use the power rule. Excellent. Now, that is one way to solve that problem. Some of you already know that there's another way, and obviously it says across the top, using the product rule. So we're going to learn about the product rule. Same problem, different approach. Now here's the thing. If you don't want to use the product rule in this case, you can multiply it out just like Dimitri did. There's no, my product rule is not necessarily a better way, it's just a different way. Again, more tools in your arsenal for attacking. He has a question?
So if we're like on the test, are you gonna ask specifically like using the product rule on certain ones, or are you gonna let us use whatever we want?
In the chapter test here, I would probably, there will be some where I will be specific and say, use the product rule, because I want to make sure you know the product rule. Later on, however, it's entirely up to you. Okay, beautiful. All right, so here's how the product rule works. Well, does anybody know? Nope. No. Nope. 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 Okay, so common mistake. Thank you, Liam. It's almost like you played into my plot. Common mistake is to take the derivative of the first, take the derivative of the second, and multiply them together. Doesn't work that way. It works this way. H prime of x. Now, you can do it either method that I'm about to show you, but I'll tell you the way that I do it. The first times the derivative of the second plus the second times the derivative of the first. Okay, so let me say that again. First times the derivative of the second plus the second times the derivative of the first. Now you're saying to yourself, self, that looks nothing like Dimitri's problem. I like Dimitri's problem better because it was cleaner. However, if I multiply this bad boy out, it will match Dimitri's exactly. And I think I don't have to do that because I think I already did it, but I'm not 100% sure. Come on. No, I didn't. Okay, here we go. 12x minus 8x squared plus 15 plus 12x minus 20x minus 16x squared. H prime of x. H prime of x. Okay, so let's see. I've got negative 24x squared. Uh-oh. Yeah. Okay. Done. I've got a 12x plus a 12x is a 24x minus a 20x is a plus 4x. Yeah. Done. And I got a little 15 on the back end. Whoops, wrong button. Yes! Same. It would be nice if every problem was this simple and you could multiply it out easily using Dimitri's method and take the derivative using power rule. Life is grand. It ain't going to be that easy. Okay. It's entirely up to you, but you'll notice that either method is the same.
Does it only work with binomials then?
I'm sorry?
Does it only work when there's like two?
No.
Oh.
No, you could even do it with 3 or 4 things. Guess what we're gonna get to eventually? 3 or 4. Not a lot. Okay. Questions about this? We're good? Okay, so here,
So if you do the 3 and the 4 things, do you just do like the 1 and the
well, we'll
3?
get there. Let's crawl before we run.
Okay.
Okay, so there it is in fancy schmancy in the maroon rectangle that we've come to know and love. If you're taking the derivative, remember the notation here. The derivative of this with respect to x, so x is our variable, is the first times the derivative of the second plus the derivative of the first times the second. And this is always a plus sign. That's just something you're going to have to burn into your melon. How many of you have seen this before? Couple? Excellent. Let us move on. I have a bunch of examples for you now. Your turn. Go. Notice it says specifically using the product rule. Use the product rule and simplify it so that we have a common answer. I will stand here and drink iced tea. So, hold on. Stop what you're doing. Theoretical question here. What will be the degree of the final answer? In other words, what's the degree of the derivative?
Third.
What degree is that? It's a 4th degree equation. If I multiply that out, it would be a quartic. Therefore, the derivative would be cubic. Good. All right, carry on. Little theoretical guess and check there for you.
One second. We'll finish.
Still works for you, sister.
So the first one, you take the first equation how it is, and then you multiply it by the derivative of the second. Yes. You add, always add, and then you take the second part, you take this part, and then you multiply it by the derivative. And then you just foil this part, like multiply everything with 3 different answers. It's pretty easy No, it's x plus 3.
No, it says x to the third.
Is that x?
All 2 answers to the same question.
Show the one.
You said
The reason it's already already x to the 0.
You are.
Oh, that's the way it is. Or the other way to think about it is it's a horizontal line. And the slope of a horizontal line.
Like, I think I'm waking up.
Adding a number doesn't change the slope of the graph, it just yeah.
Look it up.
I was thinking about that.
Minus y.
The big lesson.
What'd you get?
Click on the pen to choose your color. No, other side. I'll have to okay. Don't do yellow. Anything other than yellow. And white, obviously white wouldn't be anything. Anything but yellow or white, you're good to go.
Okay.
Okay.
There wasn't a pink option, unfortunately.
There wasn't what? I'm sorry?
There wasn't a pink option.
I'll play with it and see if I can add one later on.
Because math? Oh, that's a math. I didn't see I didn't know that. What'd you get?
Stops people now.
Fourth degree is not.
Is that what it sounds like?
Fourth degree is not the answer.
Yeah, that's why I was like,
The answer will be. The answer will be.
oh, yeah, he's got a bad
You get it wrong.
I don't know.
Well, you're not supposed to anywhere get X for column.
What'd you get?
Yeah, you're smoking. This is the derivative of this equation. I did it right the first time.
You're supposed to take this
I did it right
thing,
the
multiply
first
it by the derivative of the other thing, and the other thing.
How'd you get X over 4?
I did it right the first time.
No, look.
You did,
Here's what
this is meant to be the derivative of this, not this itself.
But you did that on the first time.
No, I didn't. This is the
Look.
derivative of that.
Look, here's what you're supposed to do.
So you do the derivative.
So you take
Take this plus the derivative of the other thing, plus this plus the derivative of the first thing.
That's terrible.
No, you're on the big and strong.
Did you get this?
Really? I couldn't
What?
tell.
No. You did it wrong. You violated the Geneva Convention.
Oh, no, I didn't put 3 in front of it. Yeah, no, I didn't.
Don't get picked up.
You might be wondering how I got it. Well, it also
I got the same answer.
Okay, save some time here. You can see derivative of, sorry, the first times the derivative of the second. That's a linear term, so it would, the derivative of that would simply be 1. That's nice because you don't have to distribute anything. And then the second times the derivative of the first. Looks good. She did some FOIL action there, and then combined like terms and got that mess. Okay? Any questions? No? Beautiful. Let's move on. Okay? So now we're going to combine a couple ideas. One is more practice on the product rule. The second one will be finding a second derivative. Now this becomes, well, hold on, let me rephrase that. What you don't want this to become is what I call a snowball effect. Okay, so you know how a snowball starts rolling down the hill and it gets bigger and bigger and bigger, creates more problems if you're in a car at the bottom of the hill. Same thing is true here. You want to be careful not to make a mistake on the first derivative, because if you do, it's going to cause problems on the second derivative. And make sure you label everything correctly. Go! Oh boy, you better work it out because you're going up to the Quotient.
Wait, not for this. This is
Oh, you said to me.
Well, I know for good.
Keep working, let's go.
I thought you were on.
Well, she bit on more than she can chew.
No, I didn't.
I don't know.
You guys know. I eat that.
Oh wait, no, we gotta do the product rule, guys. But there's weird time. Just, you know, Wait, what? X e to b plus e to dx.
Okay,
X equals to the X plus 2.
Yeah, that's what they got.
Yeah, but then it doesn't change that.
No, you just keep adding x.
Go.
We don't know how.
What's
I'm not trying to go to this.
Well, no.
What is Daniel? He's a first filler. Smart fella.
He didn't see that.
Like that? I don't know.
Hello?
Let's wait. Posey's gonna do it. We'll see which one he said.
You did not say that.
But you have to use a product for a long time, so like that's, you know,
You just keep adding.
but you wouldn't do that if it was
Keep adding
normal.
it.
What the heck?
I worked out the second derivative.
What? Let me see.
Hello? What happened?
What'd you get for P? Okay, wait. Wait.
What?
Oh, no. It doesn't look like the exponent of place. Take that. Why is it? Go after that. Use the charger. This charger is your charger.
No, you mean charger.
That's exactly what he said.
No, it's good.
I don't see this guy. I'm not 2 days out this week. I was in Boston.
What the?
I don't know if you're right.
Turned 60.
I was on a
So the kids decided they wanted to take her somewhere and she didn't. Wait, I did it. Giving you the whole family went to Boston for a long week. Go back.
What the? Oh.
No, it's
I think, yeah.
What do you think, Posey? Whoa. All right. Put my pen back.
Where did I get it from?
Where the
Oh.
little pen thing is on the front of the board.
Oh, that's cool.
Slicker than whale dung in an ice floe.
Okay.
Okay, so let's see if we can follow her work there. It appears that she took the derivative by taking the first term, which is x, times the derivative of e to the x, which is itself e to the x, plus the derivative of the first, the derivative of x is 1, times the second, which is e to the x, which gave us x e to the x plus e to the x. Beautiful. Now we take the derivative of that puppy. So you'll notice, and you probably didn't, but I'll mention it anyways, you'll notice that when taking the second derivative, we're starting to get into a repeating function here. Notice when you take the derivative of that, that's exactly what we started with, so you will see that again, which ends up right here. Plus the derivative of e to the x, which is just itself. Okay, so we're not going to go through this again because it's just a repeat of what we did up here, but you do get the same results, and the derivative of e to the x is e to the x. Clean that up. You can add e to the x plus e to the x to get 2e to the x, and you're good to go. Okay. Now, let me show you an alternative approach to it, and that is I'm going to take it from here. After Posey found the first derivative, I could then choose to do this. Okay? So that's algebra. What did I do? I just took p prime of x and simplified it that way. Now, I can use the product rule. P double prime of x. Derivative of the first times the second plus the second times the derivative of the first. Distribute, clean up. Once again, same. Posey, well done. Questions? What we will find, if we go back to this problem, and we talked about this the other day, if I continue taking the derivative of this function, what's going to eventually happen? It'll become what? No? 0, right. As we continue to take the derivative of polynomials, the degree drops by 1. So we went from a quartic to a quintic, sorry, I lied. From a quartic to a cubic, from a cubic to a quadratic, quadratic to linear, linear to constant, constant to 0, 0, 0, 0, 0 on forever. That will not happen in this case. If I took the third derivative, we would start to see more and more stuff going on. Okay? This would repeat itself, just like it did in the second derivative, and then this would just be itself. And you start to get in this perpetual loop of infinity. A similar idea happens when we start talking about trig derivatives, but we don't have to worry about that now. You take the derivative of a polynomial enough times, it will go to 0. You take the derivative of e functions or trig functions, strange things happen. We'll cross that bridge when we get to it. Okay? Questions? We're good? Excellent. Quotient rule. Woo! Quotient rule. Quotient rule. Woo. Wow. Okay, hold on. Before that makes some of you cry. If I gave you that as a quotient, you might be saying to yourself, can't I just turn that into a product rule? And the answer is yes. That's the same thing as right? The problem is, at this stage, we don't know how to take the derivative of that yet. That requires a different weapon we haven't talked about yet called the chain rule. So for now, you got to learn the quotient rule. I would like to say that later on you could forget about the quotient rule because it is nasty. But you can't. You're going to just simply run into problems where you're requiring to do the quotient rule. Later on when we talk about this other format, personally what I do is turn everything into a problem like this. When I can, and you can't always. Okay, that having been said, let's talk about the quotient rule. There it is. Now, let me explain a couple things for you. First thing I would do in this graphic is stick parentheses in there. That's actually a bracket, sorry. Stick a bracket around that thing. The single most common mistake with the quotient rule is those brackets. And if you don't have those brackets, and if you're not careful, you're going to end up making a sign mistake. And I know that if you've seen this before, if you had Hernandez last year, for instance, she taught you some Heidi, Lodi, Heidi, Heidi, Hodi, Hodi, Heidi, Lodi, Lo, right? What is it, Jessica? Yeah, whatever. It makes no sense to me whatsoever. But if you want to learn that, Jessica would be happy to lead a tutoring session to teach you the Heidi, Hodi, Hodi, Heidi, Hodi, like the 7 dwarfs quotient rule. But I'm not going to do it. I'll show you a different way that I do it. And the way I do it is very simple. There it is in English. Okay? Now, what does that mean? When I take the derivative of a quotient rule, I start by taking the denominator on the bottom and squaring it. Then I take that denominator and move it up to the top. And you'll see this in action when I take you through an example. I multiply that denominator by the derivative of the numerator, minus switching those two things. So because I took the derivative of the numerator first, and the second one after the minus sign, I take the derivative of the numerator. Okay, now let me mention, I'm going to go back a little bit. When I go back to the product rule, it doesn't matter what order I do it in, because it's a plus sign. The quotient rule order is very important because it's a minus sign. You cannot reverse those. Okay? I would like to say that this is memorization, and it kind of is, but the memorization is not something you should go home and make flashcards about this. You're going to learn this through practice. You're going to do the quotient rule a number of times, and as you do it more and more and more, it's going to become second nature. Okay, so let's do an example. Okay, start with the big honking Gesindte bar. And again, I'll take you through, I'll use my self-talk so that you can hear how I'm doing it. My method is not the only way to do it. As we've already mentioned, there's the hody, hidey, hidey, hody, minus the hoda, hada, hada, hoda, hoda method. There's pure memorization. You can just go home, make a flashcard, and memorize that. I wouldn't encourage that. But this is how I do it. The denominator stays on the bottom and you square it. Bring that denominator up to the top and multiply it by the derivative of the numerator. Minus, big honkin' bracket. Since I took the derivative of the numerator, I now take the numerator times the derivative of the denominator. Okay. That's the first part. And that's the part you should be worrying about. Getting to that stage. The idea of simplifying is going to come about later. When you're doing quotient rules, you want to simplify numerators and never, I don't want to use the word never, seldomly if ever will you simplify a denominator. You might be saying to yourself, I'm going to multiply out that denominator because I'm feeling all fancies in my pansies. Don't do it. Resist the urge. I am, however, going to simplify the numerator. Okay, so y prime is equal. Oh, by the way, I could have also done this. Either notation is acceptable here. Big honking Gesindte bar, 5x squared plus 5 minus 10x squared plus 4x all over x squared plus 1 quantity squared. Minus 5x squared plus 4x plus 5 all over x squared plus 1 quantity squared, and I'm done. I could mess around with that numerator, see if it cancels at all, and then if I could cancel, or see if it factors at all, and then see if it can't. I don't care right now. Simplify the numerator, leave the denominator alone, call it quits for the day. So the process again, numerator on the bottom squared, bring the numerator up to the top, multiply it by the derivative of let's start over. Denominator on the bottom, square it, bring the denominator up to the top, multiply it by the derivative of the numerator, minus big honkin' bracket, numerator times derivative of denominator. Simplify numerator, leave the denominator alone, life is grand. Questions? Okay. And as it says there, I already talked about that. Okay, you do this one. Theoretical question for you while you're working. Why is this an easier problem than the last one? I'm sorry? Who's talking? Talking, is that you?
Well, it was, but, yeah. No, because the numerator doesn't have an x, so the derivative's just 0.
Good. When you take the derivative of the numerator in this bad boy, it will disappear and go to 0, which eliminates a chunk of your derivative, which should theoretically make your life a little bit easier. Maybe. We'll see.
It's clearly a plus. Okay, so we're going minus okay.
What?
Okay, can I switch the color?
B board is 2 board problem.
Okay.
No, that's a good.
Oh, actually first. I hate orange. Oh my god. Do you have an undo button?
You have to go to the eraser.
Oh my god, this is such a hassle.
Because like literally this is this to like
Okay. Thank you, Via. Daniel.
Yeah.
Via made a small mistake up there. Wait, Via made a small mistake. Where is it? By the way, the mistake you made, Via,
Oh, with
is... Go ahead.
Yeah.
Well, look at that. Thanks for the help, Daniel. Good job. That's the most common mistake that people make, will make with the quotient rule, is distribution of that minus sign, and that's why I put the brackets in there. Any questions? No? Pretty easy, yes? Do we need this? No? It's up to you. Via, getting back to your problem you asked earlier, notice here, I say find the derivative of the function. I don't tell you what method. So if you wanted to multiply it out, go ahead. If you wanted to use product rule, go ahead. I don't care. Okay. Are we okay skipping this? We've done this example like 4 times now. Okay, great. Yes, sir. Whichever way you want. I would probably use product rule, product rule, or product rule. Do it and solve it in water. This believe it or not, looks like hieroglyphics, but it's actually all the differentiation rules. So you take a derivative, that process is called differentiation. Those are all the differentiation rules we've seen so far. First one, in the upper left-hand corner, the derivative of any constant is 0. You knew that. The next one over, product rule. The next one over is that crazy business with e to the x being its own derivative. The one middle row on the left, the derivative of a constant times a function is the constant times the derivative of the function. We knew that already. The derivative of a sum is the sum of a derivative. The difference of a derivative is the derivative of the differences. The product rule and the quotient rule. There's more, but this is good for now. Okay? This might not mean anything to you. That's okay. If you can go through the process, that's okay. But you will see some questions that involve this notation, which we'll talk a little bit about after you play with it on the homework. Okay? For those of you, as I mentioned at the start of chapter 3, for those of you that enjoy the mechanics of math, you will find this more interesting. For those of you that enjoy the theory, there ain't a lot of theory here. It's practice. And you need to practice this stuff. I cannot tell you how many times you're going to end up taking a derivative between now and May. It's enough to make you just cry or throw up. Or both at the same time. What's that? Throw up, yes. Or thrive.
I like cry better.
Good.
That's why I like
I'm gonna thrive.
Yeah.
Probably too.
Yeah, that's the way I think it
Without going through all the rigmarole of solving this problem, this one does dabble a little bit into theory. We defined the derivative as the slope of the tangent line at a certain point on the curve. If you take the derivative, all of these derivatives we've taken already today are the derivatives at any point on the curve. You can choose whatever x you want. In this particular problem, though, I told you what x to choose. What are the two things you need to write the equation of a line? Slope and a point. We have a point. How do I find the slope? And take the derivative and plug in, which is 1. Good. In a case like this, I'll do it quickly, you don't have to worry about simplifying because you're going to end up just plugging in x. So f prime of x is equal to x squared plus x plus 1 quantity squared. Take the denominator on the bottom, square it, bring it up to the top. Be careful with parentheses. Times the derivative of the numerator minus big honkin' bracket. The numerator times the derivative of the denominator. Again, if I was going to ask you to find the derivative, I would expect you to simplify the numerator. But in this case, I don't care, because all I'm going to do is take this little guy and plug it in there. F prime of 1. Notice notation changed. This is f prime of x. This is f prime of 1. 3 times 2 minus bracket 0. Who cares? That goes away. Divided by 9. Two turds, as Grandpa Selmer would say. Did I do my math right? Okay. Not done. That's the slope. So y minus 0 is 2 turds times x minus 1. Do you need the 0? No. But again, crawling before you walk or run. There are little things that happen that you can save yourself a lot of grief about. I didn't bother plugging in 1 over here because I knew as soon as that was 0, all of the rest of this didn't matter. It just disappears. That whole bracket thing goes away. Same is true in the previous derivative. When Via took the derivative of 9 to get 0, that whole term disappeared. Okie doke. Higher order derivatives. We're not going to do them. I just want to show you the notation. Okay. So this makes sense. The first column. Y prime, Y double prime, Y triple prime. Ooh, then we switch to 4 because writing 4 dashes is too difficult. I don't know, whatever. Y to the nth. Same thing with F's. F prime, F double prime, F triple prime, F to the 4th, F to the nth. This is a little strange. What will happen is I'm going to ask you on a test or a quiz to find a second derivative, and you're going to come up and say, what is this? Okay. The squared goes on the d, the squared goes on the x. I don't know why. That's how Newton wanted it, or Leibniz, I forget which is which. Then occasionally, somebody will get all fancies in their pantsies and use that guy. It's just a different notation. I don't know who created that notation, and it's not very common. The derivative of y with respect to x. They all say the same thing, just different notation. To be honest, we will seldomly go past this. Okay. Alex?
So on a test, when we have to use that, like, on everything, just like take the derivative and then take the derivative of that derivative.
Well, that's what it is. This isn't a formula. This is just notation. So in other words, I may give you a function. I may tell you that y is equal to x to the 7th plus 5x to the 4th minus 7, and say find this. You need to know what I'm asking you to do.
Oh, okay.
Which is exactly what you said. Take the derivative, then take the derivative of the derivative.
Okay. Like we don't need to like
No. It's the same formula. It's just taking the derivative of the derivative. Take it.
If I'm given d squared y over d x squared, do I have to use that notation, or can I use f double prime of x?
I don't think there's a stipulation on the notation that you have to use. I don't think they care. Yeah. All done. Questions? Okay. I cannot stress enough how much you need to practice this. Okay. In particular, some of you have gotten a little bit lazy on how you're attacking problems. I'm not a big fan of giving you 35 problems of the same thing over and over again. I'm trying to kick that down a little bit. Instead of having 2 hours of homework a night, I'm trying to reduce that. But that means that every problem that you do is important. I'm picking problems on the homework that are illustrating one of the major ideas that come up. Instead of doing 10 of those, you might only have 1 or 2. So the responsibility falls on you to focus on every one of those homework problems. If you struggle with any one of those, don't be bashful to ask, either in class or during your free periods or before school. But you can't let this run you over. The longer you wait to get the questions, the worse it's going to get. So even in the little bit we've done, if the power rule didn't make any sense to you, you can imagine how lost you would be with the product rule. That is going to continue as we go along. If you haven't established a base, then the further we go, the worse it's going to get. So get on that right away. If you struggle with the product rule and the quotient rule, come and see me. We'll go over some problems. Ask questions in class. Do what you need to do to make sure you understand this. This stuff is not going away. Okay? Good? Excellent. Rid of that. Discard. Come over here.